Dear students, I welcome you for the today's lecture related to the measuring instruments. In general, our process control subject that includes the process, its P&IDs, process and instrumentation diagram, in which this process and instrumentation diagram that incorporates your chemical equipments, it incorporates the instruments, and it also incorporates the electrical lining as well as the electronics part. So ultimately, for all these are related to symbols, related to the valves, the different types of the valves, the gate valve, the globe valve. Now looking at this, the control valves. In general, the control valve that is drawn like this. This is the simple symbol for our control valve. But when you go into the details of a process and instrumentation diagram, there are minute variations that is also available. And what is the meaning of those minute variations, that is to be studied. So here one upward arrow that is provided. So it indicates the control valve opens on failure of operating medium. So it is going to open. So this arrow in the upward direction, it indicates that the control valve is going to open at the fail-safe open condition. So the control valve that gets closed on failure of the operating medium. Operating medium, that means your air which is going to operate the control valve. So the failure of operating medium, that means the air. Then the control valve retain its position. Control valve retain its position. It will remain as it is. It will neither open nor it will close. So whatever the last condition of that control valve is there, the same will retain if the failure of the air that is there. And then the combination of the above two symbols that is used to indicate the safe and permitted direction of the drift. So it incorporates the arrow as well as the two lines. So it's a safe position. So again, these small minute changes, they are also necessary and important to understand the process and instrumentation diagram. Now look at this, the level indicators as well as the flow indicators. So the level indicators, that is the internal ball float type level indicator, a ball that is provided and it is connected to a flange of a vessel. So it's an internal ball float type. Then internal displacement type. This is also going to float it. But there is a small difference in between this. The float and the shaft. The first ball float is the float and the shaft arrangement, and the second arrangement, that is the internal displacement type, that is the float and tape liquid level. Float and the tape liquid level type. Then there is the different arrangements where you can have the differential pressure type level indicators. Then gauge level indicators, local gauge that is provided, that is why it is written as LG, local gauge. Then sight glass or watch glass that is provided. So all these are the different equipments or different accessories which are available in our P and ID diagrams. But what is its meaning, that should be understood from the perspective of the instruments, from the perspective of the chemical equipments, from the perspective of the electrical and electronics direction. Now coming to the flow meters or orifice plate. The flow meter that is indicated by a circle and a square, a rectangle. So inside this rectangle there is an orifice that is provided. This can be also shown like this. Then there is a turbine meter, that is a float is available. Then the variable area meter, nothing but a rotameter which is available. A vertical rotameter is always attached in a vertical direction. So that is the vertical rotameter that is available. And these turbine meters, they are mostly in our house where, where the corporation water that is coming inside. Those are our turbine meters, turbine flow meters. कारपोरेशन का पानी जो आ रहा है अपने घर में, वहां पे जो मीटर लगा हुआ है, that is all related to this turbine meter, so that the turbine or a fan type arrangement that is provided and which is going to rotate continuously and the measurements are made. Then the venturi meter that is also available, which is indicated by the reduction in the area. So all these are related to the actual arrangement, what is there in the field, and that is correlated in the symbol also. So I have taken only the few of these related to the instrumentations. Then our chemical equipment that is also there. Then local mounted instrument, a circle that is provided. In this level gauge, this is a circle that is provided, a local mounted instrument that is provided. Then the control center instrument, it is provided with a horizontal line inside a circle. Then two service instruments, two services are provided. Then comparator or the instrument transmitting, that is what we have seen it in the block diagram, a comparator. Then a pneumatic control valve. But when you talk a pneumatic control valve, it is having all the details related to these arrows and two horizontal lines. All these are the details, and one should be able to analyze the difference between that. So it is better to remember that, but even if you don't remember, it should be understood that there is some difference in the valve. That is not an error of a drawing person, but there is some difference, that it is fail safe open, it is air to open, or it is air to close. All these are the different conditions which is available. Depending on that, these indications are provided. Then electric control valve, electric motors, this is what a pneumatically operated control valve. The electrically operated control valve is shown like this. Then safety valves, that is, it is flared, which is going outside. Then our process connecting lines, a simple line process connecting that is provided. Then the orifice flow line, the flow is broken and the orifice that is provided. Then electrical transmission lines, a dotted line that is provided. The pneumatic transmission line, the lines with the two obliques, that is also provided. Then there are capillary lines or small lines. Then the line with the cross, that is also provided. So these are our all instrumentation, or you can say mostly it is related to the process and instrumentation diagram symbols. that is needed. Now the measurements are to be done, and mostly it's the physical response that is related to the different process variables. The common measurements which are there, that is temperature, pressure, flow, level, and composition, that is there. And all these are controlled with the help of a control valve. Even though I am going to maintain the temperature, the flow rates either of a heating fluid or a cooling fluid or the air, that is going to be controlled. And this flow rate which is going to control is all related to the control valve. So flow controlling is very essential, and in that flow controlling, level आपको control करनी है. If you want to control the level, then how much amount of the fluid that is coming in, which is controlled by a control valve, or how much amount of the liquid that is going out, which is again controlled by a control valve. So each and everything is controlled by a control valve, but it what we are measuring and what we are trying to control it with the help of those control valves, it is bound to be different. We can control the level, we can control the temperature, we can control the pressure, we can control the composition, we can control the pH. All these different things are there. So they must require some sensors to measure these variables, and these are our different measuring instruments. One by one we will see the temperature. In the temperature controlling, it's the thermocouple which are most commonly used in the industries. Thermocouple or thermal resistances, that is there. So what are your thermocouples? Thermocouples are the two different metal wires which are connected or which are fused at a tip. They are fused or they are joined to form a single tip, and resulting it generates an EMF, and this generated EMF, when the junction is heated, if this point or this junction or this is the fuse point of two different metal wires that is heated, a small electric current that will be formed, and this generated electric current is proportional to the generated voltage, EMF. So there is a Thomson effect which is giving you the relationship between the generated thermoelectric EMF and the thermoelectric current. So this difference in the temperature between the two junctions of a thermocouple, that is, one is your reference junction and one is your measurement junction. So these two differences in the junction of two points, that is related to the temperature difference. So the generated EMF is proportional to the temperature difference in the wire and depends on the different metals of a thermocouple. So the larger the EMF for smaller temperature difference, and this can be easily calibrated. Then there is a resistance to the corrosion and oxidation for longer functionality and accuracy of the temperature measurement, that is what is needed. Then there should be a linear relationship between the generated EMF and the temperature. Look, if it is the, in general case, when we are going to calibrate all these equipments for a particular range of operation, the generated EMF should be directly proportional to the temperature. Then there can be the different uh, materials, that is copper constantant, iron constantant, then chromel and alumel that will be used, then platinum and rhodium that can be used. These are the different thermocouple wires or the material metals which can be used. Then there are different types of thermocouples. They can be commonly J, H, K. That all depends on the temperature range. Then there is a thermowell in which these thermocouples they are inserted. These thermocouples they are not directly exposed to the fluid. So for that purpose, the thermowells they are provided. That means if it is a vessel, I am not going to put directly a thermocouple inside it to measure the temperature. I am going to provide a thermowell in which I am going to put a thermocouple, and this thermocouple measures the temperature, so that whatever the fluid which is directly exposed to this metal or a thermocouple will not get damaged because of the flow vibrations, or the corrosion and oxidation that will be avoided. So that is to prevent the damage and the corrosion part, we are using these thermowells. Next is the constant volume gas thermometer. The constant volume that is maintained and the pressure reading that is directly proportional to the temperature, and consequently the pressure reading, the thermometer indicates the temperature of the system. So in this constant volume, certain gas that will be available, either helium, hydrogen or nitrogen. These are the gases which are available in the constant volume gas thermometer, and with the increase in the temperature, the pressure that is going to change in the thermometer, and whatever the change in the pressure, noting this change in the pressure, that is going to be calibrated with the temperature. So it is used for laboratory calibration purpose. So the if helium gas is used, that is below 100 degrees Celsius, nitrogen hydrogen that is 0 to 100 degrees Celsius, the nitrogen is used above 100 degrees Celsius. The next is a radiation pyrometer. Radiations, where the radiations are received and concentrated, and they are then calibrated to give you the certain relationship between the temperature and the amount of radiation received. So consisting of this radiation receiving element, by which the radiation of an object is focused using the mirror type or lens radiation receiver. That means in our instrument of radiation pyrometer, where there is a lens which is fitted and it receives the radiations from that particular object, such as your furnace. So receives these radiations, and consequently its temperature increases, which gives the temperature of an object. Now this radiation energy received, that is proportional to the Stephen Boltzmann law, is defined according to the Stephen Boltzmann law and is directly proportional to the fourth power of the absolute temperature. Is used for the high temperature measurements, generally a furnace. Then there are the optical pyrometers. These are also used at a higher temperature. When you say optical pyrometer, so the visible spectrum range of monochromatic light beam that is used, that is what is 0.01 to 0.65 micron is our visible spectrum range. So this radiations of visible spectrum is compared with the radiations of standard light source, and the heated object is radiation source, means the heated object to which I am going to measure a certain temperature. This is the source of radiation which is to be measured, and your pyrometer, which is consisting of the tungsten lamp, is the standard light source. So two sources are there. One is the standard light source of tungsten lamp, and the second is the temperature or the body whose temperature is to be measured. So this body will also exert or exhibit certain radiations and which are detected or compared with this light brightness of the tungsten lamp. So the brightness of the tungsten lamp filament is compared with the brightness of the hot object using the telescope visual system. Then the intensity of the lamp filament is adjusted by the resistance, which consequently vary the brightness of the filament, and comparing the brightness in the visible spectrum indicates the temperature of the system. Then there are different types of thermocouple, that is copper constantant and constantant, and they are used for different ranges. Copper constantant thermocouple, they are used in between the 100 to 700 degrees Celsius. Then iron constantant, they are used for 0 to 600 degrees Celsius. Then chromel alumel, that is used in between 200 to 1000 degrees Celsius. Then in case of platinum and rhodium, they are used for still higher temperature, that is more than 500 to 1500 degrees Celsius. Then there are bimetallic thermometers, which is used in a smaller range of 0 to 500 degrees Celsius. Then the resistance thermometers, that is to 20 degrees Celsius to 600 degrees Celsius. Then the vapor pressure thermometers, where its range is still lower, that is 0 to 400 degrees Celsius. Then our general household or mercury thermometers, that can be designed up to 0 to 500 degrees Celsius. In our case, in our household purpose, it is up to 50 degrees only. Body temperature is not more than that, 97 degrees Fahrenheit or 37 degrees Celsius. Then constant volume gas thermometers, where the hydrogen, helium, hydrogen or nitrogen, that can be used less than 0 degrees Celsius, from 0 to 100 degrees Celsius, and for nitrogen greater than 100 degrees Celsius, and they are used for laboratory calibration purposes. These are constant volume gas thermometers. Then there are radiation pyrometers, which are going to give you the higher values. All these pyrometers are all more than 1000 degrees Celsius measurement. So radiation pyrometer, that is 300 to 3000 degrees Celsius. Then optical pyrometers are still 300 to 3000 degrees Celsius. And this photoelectric pyrometers, they are used in a range of 500 to 1500 degrees Celsius. Then you can have the platinum resistance thermometers, that is what minus 200 to 0 degrees Celsius, that is used. So all these thermocouples, thermometers, pyrometers, they are going to give you the different range of operation. and what is your suitable range of operation of temperature measurement, you are going to select that type of thermometer. Again, there is a distinction in between the J, H and K type that can be also used for measurement of the different range of a temperature. Range of temperature is varying. Next is a level measurement. Now, in case of a level measurement, it is the float and the shaft liquid level unit. This is generally seen in our household purposes where the overhead tanks we provide a float valve. So on that float valve, the operation of the valve, that depends. If the level of the liquid that is increased or full, the float valve that gets closed. So similar arrangement that is also used, or that float is used to calibrate the liquid inside the tank, and it can be converted into the electronic or the local signals. So if you will look at this figure, that is in a liquid tank, the float that is available and which is connected to a shaft, and this shaft, there is a wall or inside a vessel that is there, so that the certain holding will be there, that it should retain at certain fixed position. And if it is inside this tank, then there can be a stuffing box to prevent the leakage that will be there. So rigidity that should be held somewhere. Then it is connected to a counterweight so that it can change easily and conveniently the position, and then it is connected to a measuring indicating scale, or it can be connected to a pneumatic system where you will get numerical values. Generally, these are used for open vessels as well as the pressure vessels, and used in the range of 25 to 50 centimeter, very small range, 25 centimeters to 50 centimeter range, very small, that is what. So it is having a certain limitations, float and shaft liquid level units. Then next is the float type. So you can see this float type indication. So this is what a float, round float that is available, and it is connected with a lever. Then next is a float and tape liquid unit. So that a tape that is provided, float ball valve is there, or rectangular or a square float that can be used, but it is connected to a tape, and which is again counterweight by the changes in the pulley. You can measure the the level inside this tank. So if the level is below this indicated, so this ball valve will be in the lower side, as automatically this needle, pointing needle, will move into the lower direction. So that is all calibration purpose. Every instrument has to be calibrated for that particular vessel. So range of measurement for this type is 10 centimeters to 2000 centimeters, a wide range, or you can say the 20 meters तक use हो सकता है ये. Then the float used, that can be nickel plated or copper floats that will be used to prevent its corrosion. Then a thin flexible tape that is connected using the pulley over it. So change in the liquid level moves the float, and the rotation of the pulley wheel, which is connected to the pointer of the recording instrument, indicates the changes in the liquid level. So if you will look at here, the डिस्प्लेसमेंट टाइप, दिस इज द एक्चुअल डिस्प्लेसमेंट, एक्चुअल मूवमेंट हो रही है इसकी डिपेंडिंग ऑन द पुली. It is shown on your process and instrumentation diagram in this pattern. Then there is a bubbler system that is also used. So bubbles, they are generated or inside a vessel. The tube that is connected here up to the bottom, and through this tube the air bubbles, air that is compressed. Now depending on the liquid level inside the tank, there will be a generated back pressure. Level इतना है तो bubbles will move in this direction, and depending on the liquid level, these bubbles will have a back resistance, and this back resistance or the back pressure is to be calibrated for the liquid level in the tank. So these are used for corrosive liquids. The gas or air is bubbled through the pipe immersed in the liquid through a valve. At the upper end of the pipe, the pressure gauge that is connected, which is going to measure the pressure. कहाँ पे measurement करने का है? At the upper end. And from lower end, the bubbles will move inside the tank. So the pressure required to cause the flow is higher than the liquid level above the bubble pipe. So this liquid level exerts the back pressure for the air bubbles to move out from the tube. And this is measured by a pressure gauge or a differential pressure measurement instrument that is there. DP is what? Is your differential pressure measurement. It is calibration of the pressure in terms of a level, indicating the liquid level in the of the system. Then there is a pneumatic balance meter used in the pressure vessels, that is in the range of 5 centimeter to 1800 centimeter, that is 18 meters. The float is resting on the liquid surface, and the weight of displaced liquid resulting the upward force on the float, which is balanced by pneumatic servo systems. So the pointer of recording instrument indicates the corresponding pressure, which is calibrated in terms of a liquid level. Now if you will look at this, this is what a differential pressure type that is used. One pressure point is here, another pressure point is here. It is nothing but your manometer, pressure measurement is there in the is used for indicating the liquid level. So similarly, your bubbler system as well as your pneumatic balance meters, they incorporate the differential pressure measurements. Then this float and the shaft unit that is used in the range of 25 centimeters to 50 centimeters, suitable for the open vessels and in your closed vessels, and that is nothing but your pressure vessels also. Then float and tape unit type used in open vessels as well as in case of your storage tanks or so, that will be used. Then bubbler system, which is most commonly used in corrosive liquid. Then pneumatic balance used in pressure vessels. Then liquid head pressure units that shows a wide range 2 centimeter to 300 centimeter. Then ring meters, bellowmeters, air trap system, diaphragm box, float displacement unit. All these are the different units they can be used. But when in industries, it's a differential pressure is most preferred because it incorporates the bubbler system and measures the back pressure in the vessel. Then there is a pressure measuring instruments, that is ionization gauge as well as the Pirani gauge, that is also there. So this pressure instruments is mostly your manometers, they are used to measure the pressure. U-tube manometer, then two liquid differential manometer, then rig manometer, inclined tube manometer, inverted U-tube manometer, then your well manometer. So all these are the different manometers which are used. Then bellows pressure element, bellow differential pressure gauges, then Pirani vacuum gauges, ionization vacuum gauges, then thermocouple vacuum gauges, then your macloid gauges. All these are showing in the microns. So that is used for low pressure measurement. However, for high pressure measurements, it's the gauges and your manometers and differential measurements. Then there is a composition measurement instruments, that is your mass spectrometers, which is used to measure the composition of your petroleum products, rubber products, then your aliphatic and cyclic hydrocarbons, or you can say the different hydrocarbons. Then IR analyzer, that is your infrared analyzer, which again used to measure, analyze the synthetic rubbers, petroleum products, pharmaceutical products, organic, inorganic compounds. Then your emission spectrometer, that is the analysis of metallic compound. Then polarograph, which helps to analyze the alloys and ores. Then there are the X-ray diffractions. They are useful for analysis of crystalline and amorphous solids in case of your polymeric materials. Then thermal conductivity cells, the analysis of different types of gases, CO2, nitrogen. These are your used to help uh, with the help of a thermal conductivity cells. Then there are psychometer and hygrometers used to measure the moisture in the air. Then pH meter for acidity and basicity of the solution measurements. Then the refractometer, which helps in composition of miscible solutions used in your petroleum or products, refractometers. That is for the different instruments. Then there are different flow rate measurement instruments.